Good morning, everyone. Uh, so we have been working on code generation for a very long time, past 3 years, and at that time there was no LLM, and now there is a lot of LLM. So I'll be presenting some learnings. Some of them are nuanced learnings, which I'll talk about based on what we have seen, what we have heard, what people want, and the later half of this talk is going to be about evaluations, some objective parameters to back it up, to bring out what I'm talking about. Right. So briefly about me, I have been working for 16 years. I've been a hands-on coder. Comba is my third startup. I was at Microsoft Research in the start of my career, and I have built many products during this time, and I have experience with a lot of stacks. So, in Comba, in the past 2 years, we have built a Figma to code agent, which was earlier purely algorithmic, and now it is primarily LLM. And we have demoed this code to hundreds of engineers, and trying to understand what works for them, what does not work for them. And the rest of the talk is largely learnings from that experience, and then trying to quantify it as best as I can. So, last year in AI has been very exponential. Earlier, LLMs were not able to even write basic syntax completely over long, large files. They would make mistakes. They would miss out a colon, miss out a bracket, etc. All of that is gone now. I rarely see LLM making mistake when writing code, even for a very even at the length of 30,000 tokens, it goes on writing and writing. LLMs have become extremely good at figuring out what they need to search in a repo, using file tools, even able to edit tools, use grep, etc. So a basic tool like Claude Code, when connected with the earlier versions of that, when just connected with Bash, they would do reasonably well. So agentic capabilities have dramatically increased, and with MCPs we can connect Figma, and we can connect databases and context sources to LLM, which has made Cursor really powerful, right? And all other agents, in fact, Klein, Claude Code, etc. There is significant improvement in vision abilities of LLMs. Earlier, when given an image, LLMs would do very poorly. Text prompt would work much better than vision, but I think in the last year this has really caught up. So LLMs are vision is a multimodal input for LLM. It's a different kind of input. Text is the primary mode of input. So I think they have worked on this. LLMs are now much more creative, right? I tell it that I want to make a SaaS application for maybe a school, and it's able to imagine what it would be like. It's able to draft requirements, and it's able to do all of this in a single task. That behind the scenes, that it's straight away starts writing code, but behind the scenes it has figured out all of this, what needs to be there, and draft requirements for it, and build a working end-to-end product, right? Okay, product is a big word, but end-to-end working stuff. LLMs are getting faster and cheaper, right? Which has also made a lot of in-place IDE tools possible. Earlier they would take a lot of time, but now Cursor works literally hand in hand with whatever you want to do. And these abilities have led to products like Lovable Bolt, which started as a prompt to, they were literally toys earlier when LLMs were not capable, and suddenly when LLMs became capable, these tools have shot up in revenue to hundreds of, not hundreds, but tens of millions in a matter of months, which is insane, never seen before, right? So all of this is there, right? Everybody is using AI, everybody is talking about AI, everybody is saying that, LLMs are going to write code, etc. So for the purpose of this talk, I would like to explore this question, that is vibe coding really very easy for front-end developers. And front-end developers means developers who write front-end for their profession, for their day job, who need to commit code into working repos and their code gets reviewed and it's a part of code base, etc. Right? Not just somebody who wants to make a 1-pager or 2-pager app or a side project, right? So what are the front-end specific challenges which front-end developers usually encounter? A lot of you might relate to this, right? So I even 1.5 years back when with GPT 3.5, I would frequently make it write code related to AWS CloudFormation and all of these things, and it would seamlessly do it, but it would struggle anything related to front end. Primarily, I think there are these reasons. So first is that in a backend or any other setting, I can build a separate module, I can write another file, or I can ask it to code one function, and I can much more easily integrate it in my rest of the code because everything is not tied so closely together. There are microservices, there are modules, I can spin up another service and make it talk to this service, and all of this doesn't have a lot of cost in terms, API calls are cheap. So it's very easy to introduce new things or new modules in backend code, but that's not necessarily true for front end. The whole app is bundled together, it is packaged together. You might have 5-year legacy, you might be on Chakra V2 or maybe even Angular in many companies, and it's not straightforward that you just ask LLM to write a shared CN dashboard and just put it into your front end code, right? So adoption is hard. Review is hard also, because in the other parts, you can logically review the code, right? And a lot of parts you can simply skip through because you already know that LLM is not going to make a mistake there. Printing, logging, and all of those things. But in front end, every line has a lot of information, right? So many CSS attributes, so many, props, and so many things to miss out, and you will not know in the first go, right? One class is missing and some functionality will not work because some selector has been used in that, in some other piece of code, or some condition has been written somewhere else. So review is difficult. You just seeing logical blocks of code does not help you review front-end code very easily. Similarly, correctness. In many other settings, you can connect LLM to an E2B kind of a solution, a sandbox where it can run its own code, generate unit tests, and work in a loop and iterate on its code, right? Because unit testing is relatively easier, most of the code requirements and end goal is logical, but that's not the case in front end. Even running the code is very hard. It's not straightforward, right? So this loop is not very easy in front end. And then in back end, mostly stacks, the number of stacks are not, in front end, it's, I think, at least tenfold of, the different permutation combination of things you could do, right? We hear like, oh, we use Mantine, but we use Tailwind when we want to write layout, and when we do this and that, and then we have a set of mixins and blah, blah, blah. This lot of permutation there, right? So I think for prototyping and small teams, a lot of these are not a problem, because mostly, let's say in a small team, they don't many times have exact design or exact Figma. They are working largely on inspiration. That, okay, I need a sidebar here, I need a card here, I need something here. And if you prompt LLM with those things, then it's going to make something reasonable. So there's no exact requirement, but in product teams or even any sizable team, you will have a Figma handed down to you, where you would have to exact, like, this button, this icon at this distance, exactly this needs to be coded. That makes it a lot more challenging for the LLM. It has no liberty to take any shortcut there. Component library in small teams, they are largely flexible. As long as the code works, it's clean, they're fine. But in any large team, they have very strict rules about this is the way we want to use components, this is the way we want to, write our style or framework, etc. Structure, again, small teams prototyping, it's okay, it works. But for a large team, oh no, we use this particular hook to fetch this particular data in this particular way, and this is how we load our modules by splitting, and this is how we write routes only in this particular file, etc., etc., etc. Number of conventions are too many. Stacks, frameworks, again, not big problem here, but on the other end, there's a lot of legacy there, right? And performance, again, most code is performant, which LLM writes out of the box, unless you are trying to do something out of the blue, or you have a very large code base which requires, exceptional things, like, not exceptional, but some engineering is required, right? So those make it challenging. So these are the criteria which we hear from front-end architects when given a automatically generated code. They would say they would ask us these questions that does it use all possible components from my library, and does it always do it, not optionally do it. Sometimes it used my button, but sometimes it did not use a button. It just coded a button on its own. Fine for a small team, but not fine for many large teams. Not large, even medium teams. Is my styling framework used consistently? Sometimes it would just write an inline style, or sometimes it would write a tailwind class. Sometimes it would make a emotion, and many people use these in combination. It's frequently common that people say that, oh, we use emotion for writing reusable components, but for layout we will use tailwind, and etc., etc. So design tokens. LLMs have a tendency to hardcode things, or maybe if they remember, they'll use a token. If they don't remember, they'll not use a token. Again, fine for many teams, not fine for a lot of other teams. Component variant, again, if it remembered, it will use an outlined button, or otherwise it will just put a border and a background on your own button, which already has an outlined variant, right? Props versus strings. If you just give it an image, sometimes it would try to, figure out that, okay, what are the ideal props of this component, and what is the mock data, and what is actually the string data, which might need to be internationalized, etc., right? But for example, if you give a component to V0 by default, at least till a long time, it was simply coding it as a React component. It would not really try to figure out that what would be the data structure needed for this component. So these things, it does get confuses. Store, state, wherever there are multiple options, basically, wherever just given a requirement, everything you don't specify in a requirement from the first go, right? And there are a lot of things to specify, and some things you expect the LLM to figure it out itself. So there are multiple options how to bring in a data. Linting, path aliases, it might want to use, it might not want to use. Loaders, error handling. A lot of mature repositories or even semi-mature repositories have their own way of, implementing loaders, or having their error boundaries or error handling, etc., right? So all these things, if done by any even junior engineer, would not pass the code review, basically. What we have seen is, again, inconsistent behavior when LLMs write code. Whenever there are multiple alternatives, it chooses whatever is easy for it to complete the task, right? And when using it in agentic mode, it tries to search based on what it remembers, and in those things, whatever it has searched, whatever it has seen, it tries to replicate. But you will find consistency issues there. Like, it will not try to search, oh, is there a mixin which already implements this, unless you have specifically asked it. Things like these, right? And existing evaluations, they do capture the ability of LLMs to write code, and there is a strong correlation between how it would perform in SWE bench, let's say, or on front-end tasks. So, but existing evals don't specifically capture these problems which front-end developers face, right? They're largely on Python, Java, or even there are one or two papers trying to do screenshot-based evaluation, but they're very mechanical, not practical for today's user interface. So, in our experience, LLMs need to excel at some extra things to write front-end code well, as compared to any other stack. Like the amount of knowledge base which is required to write front-end code, I mean, the knowledge which it requires to hold in its memory or whatever working memory, whatever is happening inside the LLM brain. But that is way more higher in case of front-end as compared to say back-end or any other things, because it has to remember how to write your styling. There are hundreds of CSS attributes. The language itself is of course there, which is similar to any other case, but core design library components, you might have 50 to 100 design library components which again are not strictly required to be used. I mean, LLM could write an HTML element and just style it, right? So it needs to know that this particular thing needs to be done in only this particular way. Classes make sense, or relevant other components which need to be reused, and other packages and frameworks are also extensively a lot more in case of front-end. Plus, it needs vision skills. So while writing code, it needs to refer to an image to derive its specification, which is very hard for an LLM. It needs spatial understanding to get high fidelity, because once LLM passes to the transformer and after those n number of layers, the pixel level data is almost lost. So it is seeing the image through a dense layer of fog in some sense, right? And creativity, it needs to be creative, much more in in case of front-end tasks as opposed to back-end tasks, right? Yeah, and even agents find this problem when I ask it to edit an existing component. It's not able to really visualize how this component will look like. It's very difficult for the LLM, especially when half the styles are written somewhere else and something else is written and something else is affecting how it will really look. That there's a parent container or whatever, right? So tasks like make this distance more. If you just give it on a code file, it might work, it might not work, which will work much more predictably in other settings like backend or data stacks or etc. Right? So I am going to so we tried to come up with some evaluations, some metrics. We wanted to keep it as objective and as reproducible as possible. At the same time, trying to bring out these limitations with which LLMs have. There are a lot of nuanced aspects here which are not all possible to measure, but the evaluations will try to back up, or at least bring out that there are things which they're lacking, right? Yeah. So the evaluation is basically in 3 parts. So first is we are trying to evaluate how well LLMs know component libraries, and we do this on Mantine with Chakra across various versions, MUI, and the objective is that when given very specific instruction that for example, use a very particular accordion, or like and D has a segmented component, right? So when given these very specific instructions, are LLMs able to do it or not? In most, by default, if you give it a screen and you ask it to code, the code will be working for sure. So there is no question there that it can produce working code, right? But does the code pass code review? That's where the challenge comes. First part is on knowledge base of LLMs. The second part is on vision skills, that I'm trying to help you visualize how LLMs see designs and what to really expect. And third part is we are evaluating LLMs on end-to-end code generation. So we use Aider and we ask it to generate end-to-end code, and we run some code reviews on that. Okay. So knowledge about component libraries, this first part. So what we did is that, okay, what we want to measure, that how often LLMs use correct components, right? Do they use the correct prop or variant of the component? Do they override the CSS correctly? Do they set up the theme correctly, use theme correctly, or override necessary attributes of components? So all these are the challenges which LLMs face when using component libraries, right? And what we have seen is that if you ask LLM even for a very obscure component and a prop, if you explicitly ask it that do you know what this does, then the answer will be mostly correct. So it is there somewhere in its memory. But if you ask it to recall that, can you list down all the props of this component, the answer will not be 100% correct. And or even if you ask that, explain me all the components of this library, no matter how much you prompt, it will not be able to exhaustively list down these things. So recall becomes a problem, and this issue increases as tasks, the task increases. If I have given it entire dashboard or multiple dashboards to code, then it tries to find more shortcuts to what it does not remember. Right. So to test this objectively, what we did was that we processed the documentation of all of these component libraries. We used a higher language model, O3 Pro, to generate questions based on the examples mentioned in these documents. So we let's say we pick out this snippet, which is about a badge with an indicator. We ask O3 Pro that can you give a prompt which does not explicitly mention the name of the component or what needs to be done, and also an evaluation criteria that what really had to be done in this example for it to pass. Like for example, yeah. So yeah, for this particular example, the prompt would something look like, I need a circular number indicators in different sizes containing a single digit, something like that. And evaluation criteria would be whether the batch component with circle prop has been used or not. And we do this for almost, we are able to extract almost 4,000 to 5,000 such examples across component libraries. And we run this evaluation on Sonnet, GPT, and Gemini. Okay. So, like for example, this example where GPT made a mistake. It did not use the circle prop. It just used the, it just asked the radius. Yeah, another example. I need a collapsible section where header button changes to a red background with white text when expanded. So accordion button uses underscore expanded prop to change background and text color when expanded in Chakra V2. Gemini does it, GPT does it, Claude does not do it. Okay. So yeah. So these are our results. So as you can see, nearly half the cases LLM is not able to correctly satisfy the evaluation criteria, right? Across all three major models. And one more experiment we did was that we actually gave it a list of components and props which the library provides in order to solve for the recall problem, and we see some improvement in the results. Right? There is a few percentage point improvement in the results due to this. Right? So knowledge. So this is an LLM generated and LLM evaluated experimental process. It might have some errors, but it will be a few percentage points. It will not be wildly off the charts. Like this 50 is not going to change into 90 if things are going to change. So there is maybe some 5% error in the prompt generation and the evaluation, but it's not orders of magnitude. You can see that, for example, what problems also happen due to this, because component libraries across versions, they like to rename things. They like to change which props are used where. So LLM does not, when it's getting trained, when it's getting, reading code, it doesn't really know so much about, this is version 2, this is version 3, because that version is there in some other file. It's not really here, right? So this kind of issues cause a lot of problem across versions in component libraries, is what we have frequently seen. And a lot of errors are due to this because it's confusing versions. And if you give LLM a basic list of components and props, just a list of components and props without any explanation of any component or any prop, it's able to do much better. Okay, so any questions till now, or should I take questions at the end? What do you say? I think I'll take it at the end. Let me just go through, right? Yeah. So next part is vision. So just trying to illustrate what are the what limitations visions LLMs have with respect to vision. So usually object detection works well with LLMs today. Real world objects, LLMs are able to detect well. With respect to UI elements, the object detection problem is that, firstly, in the problem, the objects are of various size, right from icons which are 16 pixels to cards which can be hundreds of pixels. So the object detection problem has to cater for wide variation of objects in different sizes and different types. This is just about object detection, but let's try to focus on LLMs. So how vision skill affects image to code accuracy? So fidelity, firstly, accuracy of spacings, font sizes, borders, border widths, colors, shadows, icons, etc. So this is a challenge. Elements, when it is referring to an image and writing code, it has a tendency of missing things. Layout. So usually LLMs are able to give clean layout in the sense that the output is seldom broken. It's able, even if you, if you are able to put correct flex properties on anything, it's going to look not broken, right? So LLMs are able to do that. But mistakes are in terms of grouping, like for example, in a header, something is right aligned and it will not be right aligned. It will be left aligned because it has missed some detail there. Things like these finer points are a problem in layout. And absolute positioning is quite poor, I would say. If you have a landing page which has floating balloons somewhere in the background, etc., LLMs are going to struggle with that. They are able to write code in a layout, in a flow, and they are able to produce sound output in that, but they make mistakes here. So if you are trying to code such kind of things, you better hide them from your Figma and then give it to the LLM and then put it manually back. So LLMs cannot measure exact dimensions and colors, and LLMs cannot remember everything they see. This is the basic TLDR. So what we did was that we took some Figma designs, and from our engine we extracted important elements and their exact coordinates and boxes, and then we try when we ask LLM to predict these, and we measure basically two things: how accurate the shape was and how far apart, what they predicted and what actually is. We ask LLMs to reply us with all the objects with their coordinates in the first go. This is the first this. So the second part is interesting. The normalized CPE, Euclidean distance between ground truth and predicted box centers. So the relative error is the error it made divided by the actual distance. So let's look at a few examples to really visualize. So roughly it's not like it is not able to see, you can see it is able to figure out relative things and relative dimensions also it is getting correctly. Smaller text have smaller boxes, larger text have larger boxes, icons and all, but it's all displaced. There is a displacement error, and there is the sizes are of course not exactly correct, but there is no mathematical correlation also between the size which LLM predicts and what really is. I mean, it's not even that if it's larger, it's always going to be larger. If it's smaller, it's largely going to be smaller. So it's fuzzy. It's stochastic. So LLMs are able to capture relative positions and dimensions of elements. Positions as well as dimensions are relatively similar, but no mathematical correlation. And it's not exhaustively able to list down all the elements. No matter how much we prompted, it always gave a list which was partial. So some boxes it would always miss. Right. So even for a very simple task where you had to list down all the elements and you had to give boxes for those elements, it's not able to exhaustively do it. Like another example. So you can see how the boxes are translated generally. Another experiment we did was that are LLMs able to measure distance between two things when given when you ask them those specific questions. That, for example, if you have a button group, then you would want the gap to be 6 pixels between the button group. Let's say that's in your design. So are LLMs able to measure relative things? Even if they are able to do that, they would largely get the spacing and the layout right? So we did another experiment for this. So we came up with, we asked LLM to first generate questions on an image that give us pairs of things for which we should ask questions to this to the lower model, and then to the lower model we ask that what is the distance between these two things. Okay. So so we created a data set of questions related to the measurement of distance between UI elements and dimensions of UI elements. So we have a list of, let's say, 20 to 30 questions based on each dashboard which an O3 Pro has generated. That, okay, measure the distance between, for example, measure the distance between the vehicle details and the breadcrumb, or between the delete button and the edit vehicle button, things like this. And then we measure the accuracy over these items. So examples of questions in dataset. So what is the width of search bar? With the search I can present in the header. What is the distance between the first row and the last row of the table? What is the width of the add wallet button? What is the height of the table? What is the length of the progress bar? Things like this, right? So you can see that frequently LLMs make mistakes with these kind of questions, these kind of measurements also. So largely if you give an image, it will approximately contain those things which are there in the image, and it will approximately be spaced based on what is there in the image. But if you had a requirement that you have to absolutely exactly code this Figma, then it would require a lot of edits on top and a lot of insertions and a lot of changes on top of the LLM generated code. Still, the LLM generated code is a pretty good starting point, but the number of edits required are very high. So yeah, I mean, they're not perfect, right? I mean, there's a significant gap between what you would expect. You would expect 90% or 80%, but it's far away from there. You might think that, okay, in experience it doesn't feel so, and which is right. Right? When you actually use LLM, it might not feel that, oh, there is a 70% error here. Because while doing the task, it's mostly using repeated patterns. None of us are inventing UI from the scratch. There is no sidebar which has a gap of 30 pixels, right? Most of them have between 6 to 12 pixels and stuff like that. So there are a lot of conventions, a lot of rules because of which LLMs are able to generate code which largely looks fine. But if you look at the raw abilities, the raw errors, then yeah, it's worse than what you experience when you use it. So for the last part of the evaluation, what we did was we used Aider. We used Aider by first creating a so yeah. So if you don't know Aider, Aider is a OG vibe coding tool, which, like, is a precursor to Cloud Code and all of those things, where you just give it a repo and give it a command and it's expected to do everything else. Largely relying on the LLM only, not giving any other specific prompts, but giving it file editing tools and repo search tools and all of those things. And what we do is that we run this in a loop. So we ask it to write a code, then we build it. If the build does not succeed, we feed the errors back to the LLM till we actually get a working solution. So, so after the LLM has been able to produce a working code after a few iterations, we want to evaluate whether the code was how likely the code is to pass a review in some sense, right? So yeah, what are we trying to measure here? Is it able to use correct components and props? Given a design, is it able to, or does it by default code all the interactions and states which are apparent from the design? And I mean, if given to a junior developer, the junior developer would have to code all of those things. But when given to an LLM, does it do it by default? Does it follow common code guidelines? And we will look at this, what we mean. So metrics, we measure 5 metrics on this generated code. The first is visual parity. But how do you actually measure visual parity, right? So okay, I'll come to it. Interactivity, that how many interactions did it code by default? Code guidelines, we give it some very generic code guidelines, and we see whether those have been followed. Whether the code uses appropriate components or not, that's another evaluation. Yeah. And we did this for 20 designs across 10 component libraries and 2 models. We could not get I could not get GPT to work in time, so I don't have the result for GPT. Yeah. So as I said, we set up a agentic loop in which we try to ask it to generate code till the build succeeds, and then we try to review the code. So yeah, I already explained it. So this is the prompt which we basically use as a generic prompt, that you have to code this interface using this library. You can use emotion for styling. In some cases, for maintain, we ask it to use CSS, whatever is the default for the library. If you ask it to use non-default, the errors will be more. So we just ask it to use the default library. Like, for example, MUI has emotion, so we ask it to use emotion. Yeah, and if the error comes, we ask it to fix it like this. But we don't stop at lint errors. So the first part, how do you measure visual parity between generated code and this code? Because firstly, the generated code is using some other component library, so it's obviously not going to look exactly the same, right? And then it has missed certain elements, and the spacing is off, and everything is off. So pixel comparison is not going to work there, right? So so what we do is, we ask O3 Pro to again generate a set of questions based on the image which we fed it to it. That the questions look like, it has to come up with a criteria to evaluate whether the generated code has completed the task or not. And this criteria is basically whether all elements are present, all elements are positioned correctly, colors and styles do they match approximately, and whether elements have correct dimensions and sizes. So it looks like this. So O3 is able to come up with these kind of criteria, that there is a full width announcement bar at the very top. When given this design, there's a there's a bar at the top. So we collect 20-30 such objective criteria for each UI element, and then once the criteria is fixed for every design, then we evaluate the LLM and the cross component library on each of these criteria. So criteria is the same for all settings, right? So yeah, compare the difference between the design image and the image of the code preview and classify it as a match or mismatch. So this is the we use O3 to evaluate the screenshot again, by giving it the list of criteria which was generated earlier, and then asking it to say whether it was a match or it was a mismatch, right? So yeah, so these are some examples that, for example, in the first case it should have a selectable rows, but the LLM forgot to add a checkbox to the table, right? These kind of things. So again, the expectation is that you would expect probably it does 80 to 90% of the time, but it's not true. It does it less than half of the time. So half of the criteria at least are not met for generated preview. That's our conclusion for both Gemini and Sonnet. Code guidelines. So we ask O3 to review the code. This time we give the code. Earlier we gave the screenshot of the generated code. We asked it to measure the code on these criteria, which are pretty generic, that whether it is using theming or not, since we are using a component library, whether inline styles are there or not, styling approach, component breakdown, markup or logic, inline JSON, etc., etc. Consistent use of AI patterns, UI patterns, yeah. So this is how our prompt looks like. This is how you are supposed to do a code review, and we use O3 to do this code review and score it, and we ask it to rate it from 1 to 5 on each of these criteria. Yeah. So for example here, yeah, it has hard coded a background color, for example. It has used variables. You can see it's not like it doesn't know how to use maintain variables, but one or two places it just hard coded, right? So O3 called it a rating 4. Another example where it did not, where O3 thinks that it did not break down the component well enough, right? So generally, I think 3.5 out of 5 and 3 out of 5 means roughly 30% of the guide, 30% of the time, or roughly it is rating 3 out of 5 is what our conclusion is based on these generic parameters, right? And as you see, it makes more and more errors as the knowledge component of that task goes up. Like theming requires more knowledge, right? That what kind of theming variables are present in the component library, etc. So it makes more mistakes there compared to separate API and logic from UI. LLMs are pretty good at writing clean code and factoring code. Yeah. Yeah. So LLMs do understand component libraries. They understand most of the stacks. The issues are in consistency, and especially when you give them large tasks. And in our definition here, large task is one screen, not like telling it to code an entire app in itself. Component usage. So what we did was we first extracted a list of components using Manus for using the repository of the component library. So it gave us a list of components. We asked O3 that which components do you find in this image based on this list. It gave us a list of components that, okay, these are the components which I can find in this design. And then we ask O3 again based on the output, that code output, that do you see that this component has been used or not. So we ran this evaluation, and like here is the example output. Like for example, O3 there is a segmented component. O3 thinks that a segmented component should have been used, which it had found earlier while evaluating the design. And in the code it did not find. In the code it has something else. It's just a button, right? Problems like this. Yeah. This is a case of successful evaluation, where this thinks that button should have been used and button is used. So in 40% of the cases, it is using the component correctly. The 10% of the cases are those which are due to either the O3 first clubbed multiple cases together, that okay, code all of these things as this component, but LLM did not do that. So that's the sum part. So at least in 40% of the cases, the LLM did not use the intended component in the end-to-end task. Next, we asked LLM to figure out, what are the interactions which are present in this UI dashboard. Asked it to come up with a list of this, and then we asked LLM itself to evaluate whether it was implemented or not. So I think by default, out of the box, when just given that prompt that make this functional, LLMs mostly miss out a large part of these functionalities, is what our evaluation is. This skips coding several portions because they have a tendency to finish the task, and it's not really required to finish the task, right? So that's the conclusion here. You would have to explicitly specify that these are the features which you need to be implemented first for the LLM to actually complete the task by default. Yeah, I can take some questions now. That's what I have. Yeah. Yeah, thank you.
First of all, fantastic talk. I think what you have done is really novel, and I think I have never seen anyone doing this before. I think so. Congratulations again.
Thank you.
So I think Toda, with all the benchmarks, what you have been trying to hypothesize is front end, in a lot of the attention to detail. What front end developers are doing is like with whatever state of the art LLMs is there, like we are nowhere there. Have you published this somewhere in a blog?
No. I just got this ready in time for the talk. I mean, we knew all of those things, but we didn't have the numbers to match it because we have been looking at this for a very long time. But I wanted to substantiate it, so I came up with these evaluation methodologies and numbers. It's fairly recent. I would have to iterate on this more, and in order to publish it. Also, the rate limits and costs are prohibitive to run this. It's not very cheap to run all of these things, right? And it takes a lot of time also. But yeah.
I had one question also. So one is basically you did this RAG based benchmarks and you say that it improved performance, but it never reached like 50%. It was still 50% or 60%. So what exactly you gave the RAG full website of the documentation as the context, or what was the RAG based approach you used here?
So as I said, I just gave it a list of components and props, again to keep it objective.
Got it.
Because otherwise then you will get into this that okay, this RAG works well with this LLM and not with this LLM, and we did not want to get into all of those things. So just a very plain, these are the components present in this, and these are the props which these components accept. Just that we gave.
Thanks.
I think there is a scope for improvement there for sure. That's what, that's what we have been doing also.
Thank you.
Here. Yeah. So thanks for this visibility. This is really helpful. So have you guys benchmarked how animations perform? Like
animations?
Yeah. Like interactivity. Like when I click the button, like how does like it animates? Does it understands? How does it? Have you guys benchmarked that part?
I'll answer this from my experience. I don't have a benchmark for this. See, LLMs know a lot of things. If you ask it to animate, and if it's able to understand what code it needs to edit, for sure it's going to do it. So it knows it for sure knows how to do a fade in, fade out, slide, all of these things it knows. The problem is that in any task there are 100 such guidelines, literally 100 such guidelines. It doesn't remember many times what it needs to do, what it doesn't need to do. If you explicitly tell it, make this button like this, for sure it will be able to do it.
Great insights. If we are using multiple UI libraries in a project and you have tested for certain libraries how it is able to build that particular component, say an accordion. So how does, given an Figma design, how does it decide which UI library to choose and which would make it easier to build that component?
See, it has learned that. A lot of part it has already learned that, it knows somewhere that this is what an accordion, and even if I'm using Chakra V2, V3, whatever, this is an accordion, it knows somewhere. The problem is that when it's doing the task, it might remember that, it might not remember that. If it doesn't know that at all, then it would need a significantly lot of prompting. So we have solved this kind of a problem also for one of our customers, where they have an entirely, they have their own custom library. They have been building this SaaS product for past 10 years. And they have their own component library at all. Now, LLM doesn't know. And the names of the components are all, different. So it's possible, needs a lot of prompting and breaking down into smaller tasks. If you break down into smaller tasks, identification is different task, then coding is a different task. All of this is doable, but then it, requires a lot of engineering on top of that.
Thank you.
But for common component libraries, it knows this. We are not doing any magic, or we can't do much.
Yeah. So yes, so it's a nice talk. Thank you. And so our approach towards this, I think, is yesterday we had a talk on this where we had a well-defined design system, which was the input for the components, and even that gives them as a metadata before using vision systems, right? Your solution is basically providing a plain rasterized image. From there, you detect systems and then create functional UI from there. Is that your right vision? Maybe you have this.
So I have not proposed my solution at all here.
Okay.
I can do that shamelessly for a minute later, where I can promote myself. But this is largely about repeatable benchmarks and LLMs. Regarding solution, okay, let's. Firstly, thank you for listening through this, and check us out at Kombai. It's still in a wait list. Some things which will help you as a front-end developer are that we have built-in RAG layers for Sonnet. We use Sonnet and optimize for that for a lot of stacks. So you should expect out-of-the-box better performance in as compared to Cursor, etc. One big difference is that it does not directly write to a repo. So even when using agent mode, it does not write, it does not change your files. But at the same time, it compiles and fixes errors, including browser errors. It generates a preview URL for the generated code without writing to the repo. It writes to a shadow repo and generates a preview so that you can review the code before you write it to your repo. I think front-end engineers largely prefer that rather than some LLM going and changing things in their workspace. And we have done a lot of work on our Figma to code engine, so you will definitely get much more fidelity as opposed to using an MCP or, lovable bolt also in terms of Figma to code. So that's the solution we have for. So this is a public solution for. It's a self-serve version that people can directly start using it out of the box. For companies, we have optimized it in a different way.
Yeah. So for the companies, right here, on your left.
Oh, sorry.
Yeah. No worries. For the companies who are creating their own custom solutions, like what would you suggest them for evaluation with their output over there? So, any suggestions or?
What kind of solutions are you talking about?
So, for example, I see you have written rather than MCP, you guys are doing a custom solution for the Figma to code. What if we are using MCP and trying to make sure that the Figma to code is getting created? So, any suggestions for those things?
Okay. So, you as a developer would like to use Figma to code in your company using MCP is your question, right? Yeah. See, MCP will, the MCP is pretty generic, and the issue is that it will take more iterations, and the fidelity is also capped. I don't have a solution there. You can give our product a try. That's what I can say, genuinely. But if it works for you, fair enough. I mean, for smaller Figmas, I don't think it's going to matter. You can go ahead, use MCP, connect it to your cursor, and it will get you somewhere for sure, right? I think second part, how do you evaluate? I mean, you should evaluate whether it solves your problem or not. Give it to your developers, see if they use it or not. I think that's the ultimate test. There's no point of objectively evaluating these elements.
Hi. So I do have a question about the benchmark over here. Yeah. So I really loved the benchmark stuffs which you have shown, which was really meaningful, and it gave a lot of insights. When we think about the responsive design on a website, how does this relative distance, what we see on the Figma or how it's get rendered, how do we or how the responsive websites are being evaluated in this benchmark test, or is there any data towards that?
No. For your particular question, see, we are evaluating it in the same screen form factor as the original one, right? So, and the eval criteria are also on those screen sizes only. So, LLM produces responsive code by default. I mean, largely it produces responsive code. It won't happen that if you resize and everything overflows and all of those things. So, we know that. The objective of the evaluation is that has it correctly placed all the elements, right? And the design, if the design is just of the desktop, we don't have a responsive design for that. So there is no way to evaluate whether in the responsive it did something else or not. I don't think the result will look something different because it's going to fold the same way.
Right. The reason why I asked that question is, let's say we have a Figma for 1440 as a pixel clarity, and then now when we consider 1025, maybe if the design is given for 1440, because you have shown a Figma with that, how does it get? Does it has any responsive features out of the box, or is it again the Figma should have the responsive design for which it will be built against it?
See, if you are asking for the evaluation, when we evaluated the end-to-end output, that's why pixel comparison is a problem, that we cannot evaluate based on exact pixels. So our evaluation criteria, what O3 is generating based on our prompt, are not that is this positioned at this pixel or not. It's more semantic, that are these two buttons close, how close, are these placed below each other or not. Criteria are like that. So they are not dependent on the output screen size strictly. Of course, the same form factor, but not 1024 or 1025. Not that. The first one, the vision one. So in that we are just asking, giving it the image directly and asking it to measure the coordinates. And in that also, we scale the dimensions which are given by the LLM. So just try this experiment. Just give it the large image and ask the LLM that, what is the size you see? It's not going to be the same as the image. So even the height and width, it sees something else. So we wanted to actually make the LLMs look good, not bad actually, because our business depends on LLMs being good, not bad. So we have tried to do a lot of things in their favor, and then I have tried to bring out what are the nuances.
Great. Thank you.